So in this conversation, the question was posed whether or not there was a significant drop in the voltage coming off of the battery when the unit was under load, and because the power supply is continuously recharging the batteries, and you'll get an LED indication, you'll get a light indication when your batteries are good, meaning they're at charge, or you'll get an indication when they are charging. You'll also get an indication if there's no AC power. So, assuming that the batteries work, let's grab an NP1 power supply and let's connect the batteries and get our voltmeter and see what's happening on the batteries. We'll test it with a condition where the batteries are charged. There's no and there's AC, and there's AC incoming and DC outgoing. We'll remove the AC with charged batteries. We'll still get operation. We'll see if there's a dip, what that would look like on a voltmeter, and let's just experiment with this idea. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's take a look and see what we've got here. Got a prior video happening here, so we've got some pieces already out, which is good. Okay, what are we seeing here? We see an NP1 that I've got partially disassembled. That's fine. It's not plugged in, no. I have a 510 over here that I was using to prove that this can be powered, that the control board can be powered by a power supply other than the one that's below the back plane. Okay, so since there's no need to do that, let's just put this back together. The negative wire I know is the top terminal. Client had asked about what something was on the power supply, and I'll show that to you. Okay, let's get the positive put back in to where it belongs. This is a nifty power supply. It has a lot of logic running on it. You can, covered elsewhere in other videos, there's about a 9-minute video from the manufacturer that goes over all of the description of all of the lights. Okay, so we are plugged back in, and going to tuck these underneath, which is how they were originally. Okay, and what the client was asking about was, what was this? The client's original question was, what is the DC client was wondering, here's what the client was wondering. They had it powered with AC. Black, white, and green is what was happening here. Okay. and they were saying that they didn't feel as if...
You don't want me to
Yep,
ship?
it's just right. And what the client was, they had it powered AC. And what they wanted to do, AC coming in, AC goes to the transformer below. The transformer below brings DC voltage to the control board. What the client wanted to do was power it here, but then also have an additional power supply inputting here. And there'd be, of course, you have to plug something into this. This is the DC in. You've got to have 2 amps, 24 volts DC to power this. Whether you're getting it from here underneath or you're getting it from a different power supply, which is this 510 I have sitting here, it comes back the same way. I was explaining to the client that they have to investigate the potentiometer settings because they weren't getting the amount of retraction necessary. So where all of this started was, well, for that video, was the understanding of what's happening here. For our video, we're trying to figure out if there's a voltage drop when there's load and the batteries are connected. So you don't have to have batteries connected to obviously to operate this. It's just you'll have battery backup at that point. This should work. I've got yeah, this will work. I think. Oh yeah, this will work. I got a motor here that should pull that back. Now those potentiometers affect the stepper and how much rotation there basically is. So this will be our load, and the issue is I don't know. It's not called out on the installation instructions what is 1 and 2 that goes to the load, but we can obviously figure that out easily with our voltmeter, which we'll do, and I'll show you what I mean easily. All right, so what I need to do is put this back down because I had removed it for a prior video. Best little $25. This screwdriver is probably 12 years old or older. I'll put this back down. Okay. So now what I'm going to do is bring power to it, and I've got a handy plug with load or hot, neutral, and ground. Okay, so basically just a cable here, and I'm just going to wire this into my power supply. So we've got L, N, and G, line or hot, neutral, and ground. So I'm going to put neutral in first because it's easier to get in there when there's not a wire in the way. I'll need a smaller screwdriver. So what I'm doing is wiring this. Oops, I guess I'm not. Would have been easier to have wired that before I bolted it down. Okay. Something right there. It's not going all the way in. Got it that time. Seems like it likes the back corner. Okay. So what I'll do is I will plug this in, and we're going to get a bunch of lights that come up here. I'll drop the lights out. See it a little bit better. Yeah, the two computers speaking to each other were these two. See, they're communicating. There are 8 lights here, 4 for door 1, 4 for door 2. AC power is on. Don't remember what that one's for. Let's just go with it not being important right now. Let's check our polarity. Volts DC. I'm expecting no more than 200, but more than 20. So we'll put black on 2, and we'll put negative on 2, positive. Yeah, so we're good. So we know because we have a positive integer here and not a negative integer. Yep, this would be reversed polarity. So we know red is terminal 1, black is terminal 2. Okay, so we'll just remember that. Black is terminal 2. What we're going to do is unplug this before we stick any wires into it. I do recall saying black is terminal 2. Okay. Okay. So now our switch is terminals 3 and 4. This will be a normally open dry contact, so I would need to jump these in order to get them to work. So I'll need a little bit of jumper wire, just a little jumper wire. That sounds like it's really technical. I just need a little bit of wire so I can make contact between 3 and 4, and that should get this to work. And let's just make sure that does work. I'm surprised I don't have some stripped wire here. Okay, let's do that. Oh, there we go. Yeah. I don't use this plier very often, or these strippers. Oh, they work nice. Capri Tools, number 20010. Automatic wire stripping. Okay. So... oh, I don't think I stripped it well enough. Oh yeah. This wire is so thin that the stripper's having trouble with it. That's on 22, 20 gauge, and these wires are a little bit thinner than that, obviously. Okay, we've got some wires there. Okay, we are not plugged in, I'm sure of that. I'm going to go into terminal 3 with my jumper wire. And then we'll be ready to go to terminal 4 when it's time. So let's plug it in, and then we will see if we get proper operation. Okay, yeah, that makes sense because we're powering it. It goes through a little setup routine. It rattled like that because it's literally sitting on the metal enclosure. So let's turn it over. Let's unplug it again. Actually, we could just do this. Let's put it back in and see what happens. Good, okay. That is a good startup routine. So let's jump it. You make sure you can see what's happening. Take this, hold it here, and I'll work the jump. Yeah. Beautiful. Beautiful. And all I'm doing is completing the jump from 3 to 4. Works great. Okay, now let's unplug it. Let's leave our load connected. Let's go in with the batteries now. And we have some battery connectors. Now, these are 12-volt batteries. And without looking at the installation instructions, we know that this is 24-volt only. Now that's really important because if you have 12-volt batteries, which is what these are, 12-volt, 1.3 amp hours, there's only one way that you can wire these, and that has to be in series. Which means I have this battery, AAA battery. I got a positive negative here. That means the other terminal is negative. This is nothing different than black and red. Black and red. It's literally the same idea. AAA or AA batteries are 1.5 volts. You don't have to have that memorized. It is 1.5 volt. That's what they are. When you have 2 of these or 3 of these in your remote for your television and they're butted end to end, positive terminal to negative terminal, positive terminal to negative terminal, that's in series. That means, let me back up, there are 2 ways to connect batteries together, series and parallel. When you wire them in series or connect them in series, you add the voltages. So if I had 3 batteries in my remote, I know that I've got a 4.5 volt requirement, out of my TV remote. What happens when you put them in series, you add the voltages together. The amp hours stay the same. This battery has an amp hour on it, 1.3 amp hour. This has an amp hour on it too, meaning it's going to last so long given whatever load. Okay, it'll last until it's dead. That's expressed as amp hours. Okay, if this was continually run, it would last X time. Connecting them in series, you add the voltages because voltages are additive. Amp hours, meaning how long they'll last, is the same as just a single battery. If you were to wire the batteries in parallel, meaning positive to positive, negative, positive to positive, negative to negative, negative negative to the negative, positive positive to the positive, what you do is you don't add the voltage. The voltage stays the same whether you have 1 battery or 10 batteries. You got 1.5 volts, but what's additive is the amp hours. So what that means is I know that I have to wire these in series because I've got 2 12-volt batteries. There's only one way to wire these. That's in series. Because if I wired them in parallel, meaning negative to negative to negative, positive to positive to positive, that would be in parallel, I would get double the voltage. Oh, pardon me, I would get double the amp hour, but the 12 volts would stay the same. So that's clearly not what is needed. This has to be done in series. So what that means is, okay, so I just happen to know this, but it's definitely okay if you don't, and I'll show you why. That'll go there. Let's see. Okay, positive goes to positive. Okay, same concept as a battery. Positive to positive. Then, because it's in series, here's my wire. You then have to connect the negative to the positive. Oh, shoot. Let's get rid of that. I wasn't ready for prime time. Okay, so then, here's the bottom line. I think actually having the battery helps. Positive terminal on the battery. Positive terminal, positive. When we connect them in series, that positive is going to touch a negative, which means if we follow this, it goes to this negative terminal, which is the next battery. That negative terminal can only touch, will end up having a positive at the other end. That positive then touches a negative terminal, okay, and then back. So it's the same as this. So there's no power going to this, meaning it's not plugged in. I'm going to plug it in. We got our little startup routine. Now I'm going to plug in the batteries. Okay. Now, as far as I know, the light up here is well, maybe not. I don't recall. I have to look. Let's just jump. Yep. Okay. That works. Now, let's check our voltage at our batteries. Yeah, 13.4. You can see that, I believe. So we're getting a proper voltage out of this. Yeah, let's try the other one. 13.3 now. Let's be slick. See what I'm getting there when I do that? When I'm testing one battery, I'm going to get 12 volts plus or minus 10%. When I test one battery, I'm going to get 12 volts plus or minus 10%. But when I look at both of the batteries under the lens of the multimeter, I'm getting 24 volts plus or minus 10%. Really cool. Okay, so we know that those batteries are charged. So the question becomes, what happens when we put this under load? So, let's see if I can do this with just two hands. Let's see what happens at one battery. Okay, I am reading voltage. Let's jump it. All right, our voltage did not change. If we were to go across 2, our voltage 2 would not change. Okay. Our voltage does not change. Now, the test is going to be when we're not under AC power, will the voltage change? Meaning, power is out here. We're only on battery backup. What happens to the voltage when we put it under load? So let's get rid of the power coming in. We're going to get, well, if I measure here, we're going to get voltage. Yeah, for sure we're getting voltage because that's what's coming off the batteries. Now, hey Anna,
Yeah.
please come here. hold the black probe and make contact like this. Just hold that.
Okay.
Just hold it. Nothing's going to happen. Just hold that like that. Right? You don't have contact. You do there. Okay. Now, let's...
I lost it. I'm sorry. I gotta go in with my right. This?
No, you want... Yeah, touch the piece of metal. Let me have it. Right there. Okay. Now let's watch and see if there's change in the battery voltage under load. My jumper wire's getting frayed. Yeah, a little bit of change there. So at 24.4, so let's watch it dip. 24.3. 24.4. Here we go. 23.8 it drops down to. So there is a drop in voltage when you're under battery power. We're under battery power. Literally, there's no AC power coming in at all. I can prove that because if I don't reconnect this and I pull one of the leads off the battery, I'll then get nothing here, which I was before, obviously. Yes, yes. Well done. Well done. There we go. Now we've got voltage. Plug it back in. AC on. The LED went on. I don't know that you could have seen that. And LEDs up here are telling me I'm charging. Awesome. So there is obviously a voltage drop when we put it under load. The question becomes, is if it's not working for the client, do you have AC voltage on? Is that LED on? Right here. That green LED. This is my finger. If that's off, then you're running on batteries. If it doesn't work, you're going to want to put a multimeter on your batteries to find out what voltage. The video provided by the manufacturer literally states if you're below 22 volts, nothing's happening. It's not happening. You're not going to get operation out of it. So, multimeter, this is probably less than $30. It's the best $30 you'll ever spend. Even if all you use it to do is test AAA batteries before you throw them out, because you can't put the tongue test on it like you can on a 9 volt. Multimeter, you got to check everything. Reviewing the installation instructions are the way to survive. And if there's any questions, please feel free to reach out to us. Thank you. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, what comes next is about a 10-minute video from the manufacturer that talks about an overview of the NP1. And it also talks about, and I realized I still have the batteries connected, talks about what the lights mean near the end, the last couple of minutes or so. So take a look at that and reach out to us if you have any questions. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, you know, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you.
The AHT NP1A is designed to work exclusively with the AHT MEL motor retraction system. Please note that the NP1A will not function properly with any system other than AHT MEL devices. This is because AHT-MEL devices and the NP1A both contain computers that are in constant communication, and uninterrupted power is being constantly supplied from the NP1A to the MEL device. First, mount the power supply case using the pre-drilled holes. Next, make sure 120-volt service is off before attempting to connect to the power supply board. Each connector is labeled on the AC terminal block. L is line and is black, N is the neutral and is white, and G is the ground, which is green. Please ensure that the wires are all tightened down in the correct slots before attempting to energize the system, as reversing polarity could cause damage to the system. The NP1A has the capability to operate 2 doors independently. The terminal blocks to wire the NP1A to the MEL device are labeled CH1 and CH2. Each terminal block has 6 places for wires to go: C1 positive, C1 negative, D1A, D1B, S1A, S1B for the first block, and C2 positive, C2 negative, D2A, D2B, S2A, S2B for the second terminal block. These terminal blocks are removable for ease of installation and can simply be unplugged from the NP1A. For this video, we will be setting up the first terminal block, but the setup is identical for the second terminal block. With your MEL device, you were provided with a wire harness that has a red and black wire. Connect the red wire to C1 positive and the black wire to C1 negative. The NP1A interacts with your security system using a normally open dry contact located at D1A and D1B for terminal block 1 and D2A and D2B for terminal block 2. Connect both sides of the dry contact into D1A and D1B respectively. Polarity is not an issue with regards to dry contacts. However, please ensure that your security system is set up to close the dry contact in order to unlock the door. Feeding voltage into this circuit will damage the terminal block and make it unusable. If your security system does put out voltage, please put a relay in between your security system and the NP1A. When this contact is closed, the door will unlock and will remain unlocked as long as the contact is closed. The RX switch, S1A and S1B for terminal block 1 and S2A and S2B for terminal block 2 is a normally open dry contact. This contact is closed when the sensor in the connected MEL device is triggered. This sensor is triggered when the MEL device unlocks the door or if the bar is manually depressed. This system does not differentiate between a manual bar depression and an electronic activation. If your security system has a fire link, you will connect it to the terminal block labeled Fire Loop. This is a normally closed dry contact that, when opened, will signal both connected devices to move into the locked position and prevent the doors from being unlocked again until the fire link is re-established. This prevents anyone from entering through the door, but allows anyone to exit using the manual push bar. Now, turn on the 120-volt AC service to the power supply. There is a short boot time where you may hear the connected device make a grinding sound. If you do not hear a grinding sound, please recheck that there is uninterrupted power coming from the NP1A to the MEL1. When powered on, you will see several lights come on, but at this stage the most important is that the AC on light is illuminated. If it is not, please check your wiring and ensure the fuse, located directly above the AC terminal block, is properly installed and has not burned out. Next, connect the battery backup. Your NP1A comes with 2 12-volt batteries and 2 connection wires, one that is a red and black wire with 2 blue terminals on one end and a green terminal block on the other. The other is a red wire with 2 blue terminals attached on each end. First, take the red and black wire with the green terminal attached. Connect the red wire to the red terminal on one of the 2 batteries. Then connect the black wire to the black terminal on the other battery. Please ensure that these wires are not connected to the same battery. Then take the red wire with the 2 blue terminals and connect it to the remaining 2 terminals on the batteries. Lastly, connect the green terminal on the red and black wire to the NP1A using the terminal block labeled 24-volt battery. Please note that the battery must be connected in order for the device to be fail secure. Once the batteries are connected, your installation is complete. There are 16 lights on the NP1A power supply. The first is a set of 3 lights in the upper left-hand corner, labeled C, P, and F. The light in the middle, P, is power. If this is lit, the board has power. The light on the left, C, is charging. If this light is on, it means the batteries are currently being charged. The light on the right, F, is float. If this light is on, it means that the batteries are fully charged and the full charge is being maintained. The next light is in the lower left corner labeled AC on. If this light is on, that means that the board is receiving power through its AC circuit. If this light is off and the board still has power, this means that the board is running on battery backup. The next set of lights is in the bottom center of the board, just above the MEL terminal blocks labeled Door 1 and Door 2. These lights indicate the status of the dry contact on D1A and D1B, or D2A and D2B respectively. If these lights are on, that means that the dry contact from the terminal block that they are above is closed, and under normal conditions, an unlock signal is being sent to the connected MEL devices. The next set of 8 lights are in the upper right hand of the board in a white printed square labeled Door 1 and Door 2. Each of the 4 pairs of lights indicates something specific: board, COM, door, and LV fire. If the board light is illuminated, that means that something is connected to the Door 1 or Door 2 terminal block. It does not indicate anything other than that power is being drawn. The next set, COM, if flashing, means that the NP1A and an MEL device on the other end are sending and receiving a signal to each other successfully. If this is not flashing, but there is an MEL device connected, please check that the NP1A and MEL device have an uninterrupted connection to each other. The next set, labeled door, indicates if the RX switch is closed. If this light is on, that means that the MEL device has detected that the bar is depressed and has closed the RX switch dry contact. The last set, LV fire, is multi-purpose and is not door specific. If these lights are flashing together, meaning that they are both flashing at the same time, that indicates that the system is detecting a low voltage. This means that the power going into the system is less than or equal to 21.5 volts. Please note that if the AC power being supplied is less than 21.5 volts, the batteries will continue to operate the device until they are depleted. In addition, the system will not charge the batteries if the AC power being supplied is less than 24 volts. When the system enters low voltage, it will send 2 lock signals to all connected MEL devices and will no longer operate until the voltage is brought back above 22 volts. If these lights are alternating flashing, meaning that one flashes and then the other, this means that the fire loop has been broken. If this happens, the system will send a lock signal to all connected MEL devices and will refuse any signals to unlock until the fire loop is re-established. The last set of lights are directly below the array of 8, labeled UCA and UCB. The components directly below those lights, the black square with 32 legs, are the computers. Each door has its own computer that is not just in contact with the connected MEL devices, but also each other. That way, if they are both activated at the same time, they can synchronize their actions and unlock the doors at the exact same time. If these 2 lights are flashing at the same time, it indicates that the 2 computers are talking to each other and synced successfully. There are 2 adjustment pots located in the upper right-hand corner of the board labeled Door 1 Adjust and Door 2 Adjust. The default position of these pots is at 0, and they have adjustments going clockwise labeled 0 to F. This adjustment changes the number of steps that the motor will travel when it is activated. Please note that this will not adjust the amount of power provided to the motor or the strength of the motor, just the number of steps that it travels. Most people will not need to adjust this setting from the default. If you do adjust this setting and the motor makes a grinding noise at the end of its cycle, that means that it is over-traveling and you should adjust it back down. Thank you for watching this video. We hope this answered any questions you may have.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.